Okay, so in this video, we're going to do another system by graphing, but this time we notice that our example, this line is not in slope-intercept form. Neither is the other one. They're in what we call standard form, which is that ax plus by equals to c. So when we graph from standard form, we have two options. We can either graph by finding the x and y intercepts, or we can graph by solving for y first. When I look at that first example, I see that the coefficient of x and the coefficient of y will both divide evenly into the constant term. Since that's true, I can find my x and y intercepts. If you remember, finding x and y intercepts, you plug in 0 for the opposite letter. So if I want the x-intercept, I plug in 0 for y. If I want the y-intercept, I plug in 0 for x. So when I find the x-intercept here, I'm going to get 3x minus 2 times 0 equals to 12, giving me 3x equals 12, so x is equal to 4. When I find my y-intercept, I do the opposite, so 3 times 0 minus 2y equals to 12. The one big thing you need to make sure you note is that that 2 is actually negative 2y. Remember that negative and subtraction are the same. So when I divide, I get y is equal to negative 6. Then you simply go to the x-intercept and plot 4, go to the y-axis and plot negative 6, and then you can connect them. When I look at my second equation, I see that my coefficient of x won't divide evenly into my constant term. So I don't want to solve this using intercepts. So I'm going to solve it for y. So I'm going to have 4x plus 2y equals to 30. The first thing I'll do is minus the 4x. So I get 2y is equal to negative 4x plus 30. Divide everything by 2, which will give me y equals negative 2x plus 15. Now I notice that my graph only goes up to 10. So since I don't have room to go up to 15, I have to employ some other strategies. One thing you could do is go to Desmos and plug it into Desmos and graph that very easily. And we'll do that in just a second. But we can also remember, back to Unit 1, we have the point 0, 15. Our slope tells us how our y's change. So every time they're going to go down by 2. So at 1, my y will be 13. At 2, my y will be 11. And so then at 3, my y is 9. 9 is on my graph, so I can plot the point 3, 9. And then go and do my slope. Well, it would help if I did them in the correct spot, wouldn't it? So we're going to pay attention to my dark blue points instead of my Once I've graphed them, I can see the intersection point is, oops, right there, right? Is going to be right here. So I'm going to go over 6, up 3. So my answer is 6, 3. You can see this in Desmos by just typing them in. Now, but on your graphing calculator, you need to solve for y. But on Desmos, you can just type them in. As is. So then you can zoom it out. Oops, it's in capitals, so it won't You can zoom it out and you can see here's your point, 6, 3, which is what we found before. So now I want you to try and do this one on your own. So you see that you have one line that's in slope-intercept form and one line that's in standard form. So you can go ahead and try and graph that on your own and see what you get.